Empieza Alonso. Good morning, everybody. Today we have a great opportunity, a pleasure to have a presentation by Dr. Zohre Kurt. She has a very extraordinary curriculum in the area of environmental engineering and chemistry. And she is an awarded of the very great honor of the L'Oreal and UNESCO Women in Science Award this year. Um, I just want to mention what you saw in the banner, that she is a national resource in category 1, member of the National Research System of Senacid. Is also working as associate researcher at the Institute of Scientific Research and High Technology, known as INDICASAT. And also, she is affiliated to the University of the Universidad Tecnológica de Panamá, and she is a member of the FSU Urban Risk Center at Florida State University. So, given the pleasure to introduce Dr. Zohre Kurt, would you?
Thank you very much, and thank you for the opportunity. The microphone is not for you, it's for the live streaming, so I have to use it so that they can hear you. But can you hear me? Okay, perfect. So thank you very much for the opportunity. Thank you very much for coming. And I will try to be quick and exact, and so that we can eat the pizza afterwards. And if you have any questions during my talk, or if you have any comments, you can interrupt me whenever you want. Today I'm going to talk about the project that actually gave me the honor to get the L'Oreal Scholarship as well, the award. And it's really about looking at the problems in different way. And I know most of you are international affairs, and you might be able to see problems in different way. And I hope that this talk inspires you to find solutions of problems that you might see. My project title is called Using Wastewater for Energy Production. And I'll try to explain you briefly how I came up with it. What you see here is a map that is explaining the water scarcity in the world. What you see in different colors is the places where you have little or no water scarcity, the places that you have physical water scarcity, which means that physically in those areas there is not really too much water present. And the one in dark is economic water scarcity, which means that you have water, but there are problems for you to be able to reach it. And you see that Panama is one of them here, which means we really don't know how to use our water very well. And then the other that is like almost not colored is a not estimated water scarcity in the world. What we see really is that the problem with water is there. And it seems like it's going to continue unless we do something. And how do I know that? Because I know that the physical water challenge is here. But I know that there is actually water, but we cannot really distribute it to other people with the dark colors. And if you see what's happening in the future, it's even worse, but I wanted to give you the current situation in Earth. And about water. We use 70% of the fresh water that we have in agriculture. You know, that makes sense because we have to water things, we have to eat them. However, with that agricultural water, we lose approximately 60% of it. So we really don't know what's happening. It's evaporating, it goes in different places, it goes down to the groundwater. It's not really used by the plants. So we actually are wasting 60% of the fresh water that we have available. It's a huge problem. Another problem that we have is with energy, right? We consume energy more and more every day, and that's what this graph is telling you, that how much energy we use globally, and what I need you to see is an increased trend. So we keep needing energy, and we're using energy despite of the fact that we are careful, despite of the fact that we try to share cars, the carpool, despite the fact that we need to do public transport. We need energy to be able to survive because as a population we are growing. who is actually a bit familiar about sustainable development goals? You are, right? That's what you study. In the Sustainable Development Goals, what you see is the goals that globally we are trying to reach in order to have a good life all over the world. And just think about the two things that I was talking to you about. One was water, the other was energy, right? If you combine all the benefits of having drinkable water and enough energy, you will see that you will fulfill all those little boxes in the Sustainable Development Goals. Why am I going there? I'm going there because I want to give you the pitch of my little project that will solve the problem of those two things that I just told you, and will provide a benefit to the communities that are using this little invention, and will help achieve the sustainable life goals. And this is the project. What am I planning to do? All of us use water, right? And when you use water, you create wastewater. My idea was, why don't we use wastewater so that we convert the materials that are in the wastewater that be converted to energy, and then we use whatever is left of that water in irrigation purposes. And that's what it's all about. I'm proposing to use algae. I'm proposing to feed algae wastewater. And when algae uses all the materials in the wastewater, they will grow. And they will treat the wastewater, and this water can be used as an irrigational water afterwards. And then we can take that algae out, and we can extract the oil and convert that algae to biofuel. We will create some fuel. And even after we are doing the extraction procedure, we'll have some residues of algae, right? And you can use that residue of algae as fertilizers or as animal feed if they're in good quality. With that, what I'm doing is I'm proposing to use a waste that will have caused normally you to pay lots of dollars to clean, and we're going to be just treating it, reusing it, and then we're going to be making money because we're going to be making fuel. So, and this is really the scientific procedure of how everything will be done. So you're going to grow the algae, extract the oil, you're going to do like esterification, and you're going to have the fuel. Application of the project in bigger scales could be that you can use this fuel to really create a sustainable plant, or you can use it just overall, like in the globe. The fuel that you're going to be creating is not going to be huge. I don't want to misguide you, but this fuel might be enough just to be able to be used within the system that is actually treating the water, providing agricultural water itself, and it's going to be a sustainable cycle. So let me talk to you about the small experiments and studies that I did to show if this idea is going to work or not, because it's just an idea for now, right? In order to be able to start actually understanding if your idea will work, you need to be able to find a right culture of algae. What I've done is I have selected several different algae from environment, and I tried to grow them. For that, I needed to understand the effects of growth, and prepare like right media in order to understand if my algae is gonna grow. Then I had to set up a project, a reactor where my algae will grow and I'll supply wastewater. And that's what you see here. I got some empty aquariums. I just started very simple to see if it's gonna really work. I gave it some light. I gave it some wastewater that I got from a small community. I found this wastewater supplier, and I did this project in Turkey. I found this wastewater supplier from near the university that I was working. And the interesting part was their wastewater treatment plant was not able to treat all the waste. So what they were doing is they were dumping some of the wastewater outside the river because the capacity was not enough, which meant that they were really making the environment dirty too. So I just collected that wastewater from the inlet and decided to use it for my small project. I characterized the water, and why do I do that? Remember I told you that I want to use the algae to treat the water so my water can be in the standards of irrigation purposes. Because if I just tell you that this idea will work and I don't test if my water is good enough to feed the plants, then it doesn't really make any sense. That's why I needed to identify what were my parameters of my wastewater before and after the study. And that's what I did. And you here have the typical domestic wastewater characteristics. What this scary scientific table tells you is that my wastewater is domestic wastewater. Then I grew my algae. Here, what you see is in the reactors, as long as I provided something to stir it up, I had light and I had some food, my algae were growing, nice and solid. And this curve tells you that actually there is growth. If you're a biologist, you will know. If you're not, don't worry about it. And everything is just fine. And then I did all the scientific values of understanding that actually my algae growth was similar to other algae growths in the world. So everything is still okay up to this point. I adjusted my pH because the biggest problem with algae growth is that your pH increases a lot because of some of the reactions that are there in the algae, and your algae dies. So I needed to make a little system where it drops some acids so that my pH is constant. And this graph is showing you that actually this also is working. And then I measured my outlet parameters, which meant that my treatment was actually good enough to be able to use this water for agricultural purposes, not for drinking, not for showering, just for agriculture. What did I get at the end? I had some algae and I needed to, you see the yield here, and that is a pretty good yield for a wastewater. How do I know that? I know that based on how much food I give and how much growth am I gonna get. So my growth was pretty okay. It was 50% of the food that I gave was converted into mass. And here what you see is, and if the lights were a little bit better, you would see that they are actually a bit greenish. It's not like sludge. I filtered my algae using cloth. Why did I do that? Because at the end of the day, I wanted to show that you can actually do this type of treatments in small scales with using very, very cheap material, and you actually can be able to use this algae to convert it to fuel. And that's why I didn't use complicated filters. I tried to do everything as simple as possible. And you see here my algae. Then what did I do? Okay, you have the algae, and what are you gonna do? You need to dry it. I sun-dried my algae. And then I did lipid extraction and trans-esterification. What does that mean? I added some chemicals into my algae mixture in order to get the oil out to be able to make biodiesel. Who knows how you can make biodiesel normally? Biodiesel usually is made of waste oil, right? You might have heard it, that people go and collect the reused oil to like baking purposes, or maybe they are using canola oil in order to get biodiesel done. Let me tell you the story about that. So whenever you have a biofuel, your biofuel has an energy value that is a lot greater than the fossil fuel. And if you use just biofuel, you actually can use this biofuel in jets. So you can use it as jet oil, and you can power like airplanes. But producing this fuel is a bit costly because then you need to use lots of wasted oil, which if you use wasted oil, you face the problem of smell because it always smells whatever you cook it. And then you really don't have that much wasted oil to power your planes with it. And if you use canola, or if you use rice or corn, then you're using something that you could have used as food, and then you're converting it to biofuel. So as international affairs students, you will have asked me, like, why would we do that? You know, we have a big problem of hunger, right? That's why it's not really wanted, and that's why people have moved towards algae, because algae were something that was not used as food. The problem with algae was that you need to use big ponds, and you need to put lots of energy to be able to grow them. So keep that in mind, because whatever I'm trying to sell you also has side effect. And just think about the project, if this project actually will be able to satisfy this need, or will be able to answer the negative parts that are coming with algae growth. And one more key point is that biofuel now is very needed because people want to do ecological fuels and renewable energies, right? And in Europe right now, the fuel, up to 15% of the fuel that is used contains biofuel, which means that there is going to be a need in the future, and it's already a need, of making more biofuel of something. And that's the key part. So, lipid extraction. I did extract some oil, lipids, of my algae. Then I added sodium hydroxide, which will cause the esterification reaction. Creates very nice 2 layers. I divide it, and I wash it, and at the end I have my biodiesel. I'm going to show you a couple of tables. What do those tables mean is if whatever oil I got was similar to the previously published oils of algae, I'm just trying to make sure that whatever I do is not mistake and it's similar to the previous studies. And this is the first tick. Yes, my oil is really similar to algae oil, and my biodiesel is similar to my algae biodiesel. And it stands within the requirement of the diesel parameters that are reported in European Union, EU. What does the project's overall results tell you is that I do have a treatment of water, and I do have an okay amount of biodiesel production. Let me show you the yield calculations. So for every liters of wastewater, I was able to produce 0.4, let's say, because it's 2 trials, grams of dry algae, which will refer to between 0.1 to 0.5 milliliters of biodiesel. It's very little in terms of liter of wastewater that we are using, right? Who knows how much wastewater do you produce per day? Just to make sure that if my project is working or not, let's do some math. Because if you're going to buy it, you need to know how much I'm producing, if it's worth. So the water used by average American liters of wastewater is going to be roughly half a liter. Do you think that will be enough for you a day per person? But remember, you're using 5 to 15% of it in the fuel. That's more than enough. How much fuel do you use per day in your car? You don't know? Your tank is usually like roughly 60 liters. How often do you fill your tank? Every month? Every 2 weeks? Every 2 weeks? So for 15 days, you actually are using like 2 liters of fuel a day. More or less. 2 liters of fuel. And if you were to have the highest value of biodiesel, which is 15%, 15% of 2 liters is 0.3 liters of biodiesel that you need a day. So you are producing more with the amount of wastewater that you actually are creating a day. That means that actually the idea has a potential to work, right? So here I showed you that there is a different way of treating of domestic wastewater. You don't really have to use always a wastewater treatment plant. I showed you that there is a different idea that is working of production of biodiesel, and that you can do that with a unique design system. Let's see what the world is doing with algae. If you don't have wastewater, but you have lots of fertilizers or chemicals to use, which is more expensive, there are different algae ponds and reactors and photobioreactors that right now Europe is using to produce 15% of biodiesel that they need for their fuel. And roughly, to tell you what is going on further in the world, is that refineries of algae productions are being built all over Europe. And I'm just showing you like what the refineries are based on, open ponds and power generation emissions. What does that mean? People use actually the fuel, the gas that your power generation factories are producing to put it inside the ponds to make algae grow more. And those are different ideas that can be explored for future studies. You can grow your algae at home in any setting. You can do it in your plastic bottles, you can do it in your aquariums, you can do it in anything, basically. It's quite easy. And with a similar project, you actually can create a small power plants all over the world if you have small reactors of algae and you're using your own wastewater. And that's something that I would dream about for the future, that everybody actually is treating their own wastewater and having some fuel in their house, and meanwhile can use it for irrigation. With that, I want to show you one last map. What you see here is all the power plants that are in the entire world. But if you have a single algae power plant in your house, then all this map will be covered. And everywhere will be actually a small power plant. With that, I want to thank you for listening to me, and I'll be very glad to answer any of your questions. This was the project that I proposed to L'Oreal and got the award. And here are all the entities that I was affiliated and helped me come up with ideas and continue doing the work that I'm doing. Thank you very much. Should I keep the microphone, Pedro? On, okay. Yes, please.
Nice, thank you.
I hope it was short enough.
Couple of things. One of the questions I have is, I know you were doing experiments to see what the growth rate were of the algae. And I think I understood you were using raw wastewater, so raw wastewater. I wonder if you got a sense from this treatment what was their full reduction, and if the parameters that you were measuring, and what would be the scale or time that would be required to meet at this point in time a plant like that, the standards that are in Panama, for example, to meet national standards, okay? The Copanit. Okay, so what would that require? And the follow-up to that is, I know that with algae, one of the big parameters for the biodiesel industry to tackle, and they have tackled that for now some time, is the mixing of the solution that you're doing and the bubble size. And depending on what algae it is and what the bubble size, those two mix together, they really get you to optimize your ability for that algae to really extract. And whether you had or you're planning to do some experiments with bubbling and bubble size, so to get that kind of fine-tuned.
Well, of course, first thing that I need to do is, this is not a complete work unless we really have a solid state reactor or a place. You're right, I'll continue doing my work. Things that I didn't mention when the entire talk was, one, usually when you have a refinery, you're using a single culture algae and you're trying to modify its growth and you're trying to make it grow like big and fat, and so that you can have lots of oil and you can extract the biofuel. My aim here was not really using a single cell algae or even promote its growth. My first aim was to define a system that could treat the wastewater. And that was all my first goal. Because of that, I had collected strains that could be grown in natural conditions, and they don't have to be kept pure, and they could work in synergy with other cultures. And that's what I did. And the strain that I selected was readily available in the wastewater already. And the nice thing about Panama is that Panama has the perfect conditions based on what I've discovered in the lab of sunlight and of heat, everything constant, that the system can just work outside. Your question was the wastewater parameters. In 15 days, in a batch reactor, I saw that the wastewater parameters were decreased into the national levels of irrigation water. That means that you cannot really use this water to drink or shower or do anything else, but you can use it to water trees, to water some of your plants. Probably not great for hydroponic systems, because for that you need to use a membrane, because you just need to have the water itself. But of any type of growth that requires the earth, you will be able to use that water. 15 days in a batch reactor. But that doesn't mean that this has to be a batch reactor every 15 days. This can be modified to a continuous reactor, which is one of my goals. Whatever I did was the cheapest way, but designing and operating a continuous reactor will cost a bit more, and you have to invest. The first investment is going to be higher. About bubbling, the mixing that I did with the entire tank was air-based bubbling. So I was able to provide enough mixing for the culture, and they don't need really oxygen or any other bubbling anyway. To be able to extract the oils, I did use the bubbling technique as well to be able to extract more. And of course, that being set up in an industrial level is a different problem. And what I envision in the future is that probably every community can have like an algae reactor, produce the algae, but probably the extraction of oil and doing the byproducts can be combined in a refinery somewhere else that is close by. And that will increase actually the cost that is put on, because it's costly to separate the oil, it's costly to use any type of cold press. You need to produce a lot more, then you're gonna have problems with storage, and then you might have problems with smell. Then you need to figure it out where to dry the whole thing, which there are different ideas and projects that you can do that. So that's really not viable. And one more question you had, which...
You covered all of them.
Okay, cool. Any others, please?
I wasn't very clear on the process of how you extract the water from the algae. You take the water with the algae. The algae is inside the water.
It's cleaned. Then I just use a cloth. I pour my water. The algae stays on the top. I filter it. The algae stays on the top, and then my treated wastewater goes.
The algae, it consumes space in the water for its growth.
Exactly. That's what happens. Questions? Yes, please.
So you need 15 days for it to be able to reach a level in which you can dump it in the river streams, right? Because if it's irrigation water, then that means eventually it will end up in the river streams. Does that mean that you also have a need for 15 different pools of treatment water? Or can you dump every day? Can you dump every day your wastewater?
You design a continuous system. You have a much larger reactor which has a hydraulic retention time of 15 days. That's why they grow in ponds. Or you might increase their growth by providing some light during the night, luminescent light, which can be achieved by, let's say you have solar panel charged lights, and then you put them inside the reactor, and during the night you can turn it on, and then they grow more. And then you will need less time to achieve your goal. So the rest is engineering, really. You can modify them and you can make them do the job faster by engineering the whole system. You can trick them.
The harvesting process for the algae.
For the harvesting,
Whatever I showed you was simple filtering. And there are many different ways of harvesting algae. So depending on how much you want to have how much yield you want. So how much of the algae you want to capture. Filtering is one. You can do nanofiltering. You can do capturing by electricity with beads, the electromagnetic structure of the algae can be collected with some beads. That's a new technology that has been developed. So there are many different ways of being able to collect the algae. But because this is microalgae and it's not something that floats on the top and it's all mixed, you definitely need something related to filtering, and that's the most costly part of extracting the biodiesel, really. No, you can if it's biodegradable. Why? They use the carbon source. So it's lignin inside the toilet paper. So if it's dissolved, you can just use very little amount of lignin in the irrigation stream too, depending on the concentration. Any other questions? Yes, please.
I used to work in a wastewater treatment plant, and treating wastewater is very, very expensive, so I think it's a great innovative idea came up with.
Thank you very much. I did work there too, that's why I came up with it. Oh, any other questions? Thank you very much. I think you're pretty hungry, so.
Okay,